Okay, question number 55 in chapter 6. This is kind of a conglomeration here of all our different triangle stuff we got going on. So we're probably going to use a variety of different things. And so let's see what we can do here. This first one, there's actually a number of different ways we can do it. Let's see what we know though. So this side is 37, this side also has the same marking, that's 37, that's 52, that's 52, and then we can find that third angle there. We do 180 minus 52 minus 52, that gives us 76 for this angle here. So one thing we could do is law of sines, right? Sine of 52 over 37 equals sine of 76 over x, which is probably what I'm going to do. Otherwise, since it's an isosceles triangle, some people might want to recognize this as dropping the vertical altitude in here, and you have two right triangles, and you could solve using this right triangle on one side for half of x, and then just double it. So if you like doing right triangle trig, by all means you could do that, but in this case, since it's not a right triangle, I'm going to stick with the tools that we are given to solve non-right triangles, which would be the law of sines and law of cosines. So the sine of 76 over x equals the sine of 52 over 37. And so then we're going to cross multiply here, right? We're going to do the sine of 76 times 37. So sine of 76 times 37, and then we're going to divide that by the sine of 52 to get x by itself. So divided by the sine of 52, our value of x is, let's see what that's, a 45.56, somewhere around there. Sounds good. Okay, so that was using the law of sines. This next one here, well, it's definitely a non-right triangle. We have one angle, so this looks like a law of cosines relationship. So x squared equals 16 squared plus 7 squared minus 2 times 16 times 7 times the cosine of 31. Now I don't have a fancy calculator with me, so let's see if we can figure this stuff out here. So we got 16 times 16 is 256 plus 49, so 7 squared is. And then I'm going to subtract a whole bunch of stuff. So I'm going to put this in parentheses. I'm going to subtract 2 times 16 times 7 times, and then we want the cosine of 31, so I'm putting that in another set of parentheses. So the cosine of 31, close that parentheses, close the final parentheses, to give us 112.99. That is x squared. So it's like 113, right? Take the square root of that to get what x is by itself, so somewhere around 10.63. Okay, which seems reasonable. Right. Next one. Well, if this is 5 degrees, and this is 85 degrees, that's 90 degrees, which means this angle may not look like it, but that's actually a 90-degree angle, right? Because 180 minus 85 minus 5 leaves us with 90, which means we can use plain old trig for this. So pick your favorite angle. If you want to use the 5 degrees or 85 degrees, really doesn't matter. I'm going to use 5 degrees. So this is our angle. X is the opposite side. This is the hypotenuse. So that is a sine relationship, right? Opposite and hypotenuse is sine. So the sine of 5 degrees equals x over 3046. When we cross multiply there, we get x to be 3046 times the sine of 5, so there's the sine of 5 times 3046. So our value of x is, of course I don't remember what that was, 265.48. If you wanted to use 85 degrees, that would be fine. It would then just be a cosine relationship. So the cosine of 85 would be x over 3046. Okay, what do we got here? It's like a Pythagorean theorem. I don't know any angles, so I can't use trig. It's a right triangle. I have all three sides, so let's use the Pythagorean theorem. So a squared plus b squared equals c squared. So x squared plus this whole thing, x plus 7 squared, equals 13 squared. So x squared plus, some of you may need to do a generic rectangle to multiply this out, otherwise this is just a binomial being squared. So x plus 7 squared is not x squared plus 49, it's x squared plus 14x plus 49. And 13 squared is 169. So we do some simplifying here. We get 2x squared plus 14x plus 49 equals 169. I'm going to move this 169 to the other side, which is negative 120. So we get 2x squared plus 14x minus 120 equals 0. I'm going to divide everything by 2 to get rid of like this coefficient. And so we have x squared plus 7x minus 60 equals 0. Move up here, we got some room. So now we're going to factor this, right? We want factors of 60 that will give us, well, factors of negative 60 that will give us 7. And so this is where we would probably use, you know, our box and diamond type thing, more so our diamond here, our generic rectangle, to try and figure out factors of negative 60 that give us 7. So we just got to think of some factors of 60. 61, obviously not going to work. 30 and 2, not going to work. 15 and 4, not going to work. 12 and 5, that sounds like a winner. So our factors are 12 and 5. Now we just need to correct signs. We want positive 7 and negative 60. So how about plus 12 minus 5? Which means when we solve each of these equal to 0, x equals negative 12 or x equals 5. We notice that negative 12 is impossible. You can't have a triangle with a side length of negative 12. So we throw that one out. So our only valid answer would be x equals 5, which makes a 5, 12, 13 right triangle, which is a Pythagorean triple. Okay, so we had law of sines, law of cosines, some regular trig, some Pythagorean theorem with binomial in there, which is nice to see. So a lot of triangle stuff going on, right? So depending upon the situation, you have to choose the appropriate tool, and you know, just like, you know, when you're building something, right? Every tool has a specific use. That's what we kind of find here, right? Every geometry tool has its own little specific use to solve for a given situation. You just gotta know which tool is right for your job. If you have any questions or comments, feel free to leave.